All right, we're good to go. Thanks. So my name is Daniel Faber. I'm the CEO of Orbit Fab. Gas stations in space is the tagline, refueling satellites in orbit. I'm a mechanical engineer, built a dozen satellites before starting companies. Orbit Fab is the fourth company. And when we sold the third one, I was talking with my friends in the industry about how the huge paradigm shift from making rockets reusable, the huge effect that SpaceX has had, and asking what it would take to make the satellites reusable. I eventually asked, what is the marginal revenue that you'd get if I could get you 1 extra kilogram of fuel in orbit? Absolutely shocked. The answer was $1 million per kilogram. I called 7 or 8 friends and got the same answers and realized you're on two exponentials. You've got to buy everything up front and launch it and carry that cost for the whole life of the satellite until the end. So you're on the cost of capital. And you're in a second exponential, which is dragging the fuel around. Imagine buying a car with 10 years of fuel. You've got to drag that fuel. Most of the fuel gets used up dragging the fuel around. And what that means is it's not worth putting any more fuel in up front, even if it's $1 million per kilo of marginal revenue at the end. But if we can run just-in-time logistics, if we can get you fuel right at that end, I can launch that fuel for $1,000 to $10,000 per kilogram, and it creates $1 million per kilogram of marginal revenue. That's 2 or 3 orders of magnitude arbitrage. I'd never seen an opportunity like this, especially on a $10 billion opportunity. So that was it. I turned down checks on other things I was looking at. We went all in on Orbit Fab. Next slide. We had to believe 4 impossible things before we could really go in on this business, because this isn't a new idea. People have been talking about this for 40 or 50 years. But the first thing we had to believe was that you could autonomously dock satellites together. Effectively, we needed a self-driving spacecraft. The second thing we needed to believe was that we could build that interface, the gas cap for satellites, to operate in a vacuum, plasma, radiation environment, not leak fuel. The third was that we could actually get people in this conservative space industry where historically you've never been able to go up and press a reset button. We have to get people to adopt that gas cap and put it on all of the big assets. Some of these are $10 billion assets. And then the fourth thing was that we had to be able to believe that we could close the business model where we invest in this technology. We have to convince people that it's real. We may even have to put inventory in orbit. We spend all that capital, and then they buy a gas cap. Then they buy the interface, and they wait for 5 years or so until they run out of fuel. So we've got the normal valley of death plus an extra few years. So I've got 4 impossible things that we could believe. We are now ticked off 3 of them and almost ticked off the 4th. So let me tell you about the journey. It seems inefficient, costly, and just plain dumb, but it's because of these impossible things that no one has done this yet. So go to the next slide. We put together a team that had done these kind of things before. So my last company was selling thrusters. Before we had a thruster designed, we leveraged sales of thrusters into being the prime contractor on selling whole satellite constellations. So I'm used to selling things before they exist. Our chief revenue officer or chief commercial officer, Adam Harris, he was VP of government business development at SpaceX, telling the government they were going to land rockets on their tail. Everyone in government said that you're crazy and that can never happen. It breaks the laws of physics. And we know what happened there. He also spent a few years on the Hill, Senate Intelligence committees, and then a couple of stints at the NRO. He really understands the government business. Sean Hendricks, also 35 years in the Navy, flying Navy satellites. These guys know everything there is to know about big government satellite national security missions. Sean was also at Terran Orbital building some of the smallest, most dynamic, fastest missions. Other phenomenal people, but go to the next slide. We took this team, went out and confirmed those numbers. Here's a couple of the quotes, and we've got a book full of these kind of quotes, right? Space Force said it's $800,000 per kilo value just on delaying asset replacement, right? There's that almost $1 million a kilo value again. But the crux of it is not that. The thing that let us solve problem number 4, that business model problem. And the reason that Space Force exists is because space is now a competitive environment. There are competitive nations out there that are poking at American satellites, and they know that we have 1 tank of fuel, and that we can dodge 10 cannonballs, and they have 11 cannonballs, right? They can run you out of fuel. You're a sitting duck if you can't refuel. So that is why Space Force exists, and they're desperate to get sustained operations, to start getting logistics in space. That is how America is the prevailing country in this world and can project force around the world, is because of the logistics, and it hasn't existed in space. So next slide. We've then picked up 40 million of contracts. We've collected on 25 of that, 15 of that is backlog. I want to point out the second last one, Defense Innovation Unit. They're buying fuel for delivery on orbit. We're being prepaid for that fuel. It established the price at $200,000 per kilogram. It established that the terms, they pay 98% of it before we deliver on orbit. It's prepaid. And because we have that, it's the only contract that a company's ever had for delivering fuel on orbit. We can be sole sourced on plus up contracts. So we're talking 9-figure contract increases on that with no competition. Next slide. That's because the government's prepaying. We've got commercial companies that are optioning fuel on orbit, and we're putting together a take or pay forwards contract structures for them. We have clear line of sight to about 400 million of revenue 2028. We've already been doubling revenue year on year for the past 5 years. Next slide. Here's how it works. Here's the key technology. We've built the gas cap for satellites. We've built the refueling interface. Previously, satellites had a valve there to fill up on the ground, and they basically welded it shut. They locked it in and covered it in insulation. We had to develop an interface that could work in that environment. That was finished last year. It's fully flight qualified. It was approved for inclusion on some of the biggest national security assets. That is now a solved problem. Every time that a satellite puts that on there, they replace the valves. It's the same size, weight, and cost as the valves they currently have. It gives them the option to refuel on orbit because it's compatible with their active side we call grip. And that little fuel delivery vehicle there can go to multiple customers delivering fuel. When it runs low on fuel, it stays in orbit. We launch more fuel and it can pull it out of that tank and keep delivering it. So it's a very cost-effective architecture. No robot arms needed because we directly dock with that interface. Every satellite that has the Rafty is locked in then to our refueling network. Next slide. So here's some of the things we've flown in orbit. We went to the International Space Station. The first year that we're operating, we flew a couple of demonstrations up there, realized we had to build that interface ourselves. There was nothing that existed. So we built the interface and put it up on the first depot. That's currently in orbit with fuel in it. And we've been working with some of the biggest national labs to do all the testing for the rendezvous and docking, give them confidence that this is going to work for those contracts that we now have to deliver fuel next year. So by this time next year, we'll have assets in orbit. We're delivering fuel for the US government. And that's when everybody has said, this is game on, right? You prove that once in orbit, and we're going to come and beat your door down. All the commercial operators want it, and they want it paid for by the government. That's what we've delivered. So next, here's what the interface looks like. So you can see the little block of metal there. That's what you have to take on the satellite. We sold 52 of them since we got that qualified last year, which meant that our addressable market, like you have to have that gas cup on there before we can refuel it. But every one that we sell it for $30,000. It's 50% gross margin. That's almost irrelevant. Every single one is 7 million of expected revenue. So our serviceable market last year went from 0 to 360 million. Next. We've really created this industry with the thought leaders, but the things that we're building is not just storage and delivery of fuel. Our future is to build the industrial chemical supply chain in space. There are now companies that are looking at manufacturing in orbit. There are companies that are doing tourism and habitation in orbit. There are companies that are going to need a lot of industrial chemicals, air, water, 3D printer feedstock, minerals to grow plants, you name it. This is the future of the space economy. What we're building here, next slide, we're going to be able to ingest material and build the refineries and build the chemical processing on orbit. This is our 100-year, multi-trillion-dollar company. The first step is supply and delivery, storage and delivery. The first step is that gas cap. It gives us access, gives us a platform that the entire in-space economy is going to be built on. So that's Orbit Fab. We got some great investors. Next slide. We're the first company to have both Lockheed and Northrop Grumman invested in us. They realized that if the government made this interface a requirement, that if they didn't have access to it, they would be bidding on multi-billion-dollar contracts and not be able to win them because they wouldn't be compliant. So because they both came in, no board seats, no information rights, no rights of first refusal, all they got is access to the tech, and they know that if there's a change of control, that side letter goes away. So it's set up for a bidding war if we ever decide to go down that route. We got Munich Re, one of the biggest insurance companies. They insure satellites and rocket operations. They realized the whole risk profiles were going to change, so they jumped in. And 8090 Industries, this is a VC fund, but it's run by the Osman family that owns Sierra Space and Sierra Nevada. So I'm up to my eyeballs here in strategic money. Also want to introduce Rob Ness. Rob's one of our early investors and repeat investors and has been a real partner of the company. Do you want to say a few things, Rob?
Sure. Daniel has talked about the fight of bringing this company into existence and winning the contracts, building the technology, getting it into space, and winning the customers and the revenues. I think the best contribution I can make to this audience is, I'm not the builder, I'm the investor, so I get paid to sort of step back and think about things. So let me talk about the big picture. And he alluded to it. He talked about a multi-trillion-dollar company, the 100-year vision. Why is there not much in space? Because it's space, right? It's empty. If you think about, even though space is trendy now and it's a booming industry and it's a booming ecosystem for venture investment, really all we have essentially in terms of commercial space is rockets that go up to put satellites that go around. Why haven't we built as a species, why haven't we built anything else in space? It's because it's a chicken and egg problem. There's nothing there, so there's nothing to build on. So the only thing that makes commercial sense is to put something that happens to go in orbit, and then you can do the stuff that satellites do. You can do imaging and GPS and telecom. The reason I think Orbit Fab could end up being maybe by far the biggest win of my career, and maybe one of the most important companies of our time, forget about just my portfolio, just of our time, is that I think this company is changing what the space industry is, because they are creating the first thing you need in order to build in space, which is fuel. Because when you bring fuel, then you can bring a supply chain, and then you can start building things because you have supplies and resources and the ability to get energy from the fuel. So why am I really invested in Orbit Fab? The fact it's selling fuel for $200,000 a kilo, that's part of it. And the fact that they did $11 million last year and are on track to do $400 million in 3 years from now, that's a big part of it too. But the real reason is because just like coal led to steam, which led to steam-powered boats and steam-powered trains, and just like oil led to automobiles and highways, I think this is the company that's going to allow us to build and expand, not just into orbit, but across the solar system. I think this company is going to take our species across the planets. And that's a 100-year journey, but it's one I'm very excited to be a part of.
Stick it on the next slide. There's a bunch of questions. Hit me.
I have a question. So I was having an idea brewing for a bit. And there's a saying, the closer that you go to the money, the more you have. So what about space banking and space vaulting? They say, the closer you go to the money, the more you have. There's no money in space.
A lot of money is spent putting things in space.
No, I'm saying the money isn't physically in space.
Yep.
As in the gold and whatnot. Space vaulting, is that something that's possible?
The last company I ran was our big, hairy, audacious goal was asteroid mining. It was asteroid mining.
How many resources?
Deep space industries. Yep. The products we built, the technology strategy was to build the thrusters to move satellites around that could run off the material you could get out of the asteroid. Right, which you can see is an obvious lead into doing Orbit Fab. But we were looking at things like, can we securitize the assets that are the minerals that are in the asteroids and use that for, even on a blockchain, like, can we then use that for financing? There's so many different ideas. It gives you a start of a thought of how big the in-space economy is going to be. Right? There's more material on the smallest metal type asteroid that's flying close to Earth than we have ever mined in the history of humanity. The material out there is immense. We got invited to be in the Technology Pioneers program, the World Economic Forum. And at the first meeting, they said, why are you here? Tell us what you hope to get out of this. And I said, I hope to change the name of this organization. Because within 50 years, the economy in space will be bigger than the economy on Earth, and you can't call it the World Economic Forum anymore. There's a lot of things that you get out. I like it. Please.
Oh, yeah. Amazing. I'm a huge fan of space. I was involved in space with planetary resources with Peter Diamandis.
Oh, fantastic.
Back in the day. And,
the competition.
Lone Star.
Yeah. So Chris Stott is on our board of advisors.
Yeah. So you're focusing right now, up to the entry point is the pump, not the pump, the valve.
The interface, yes, the
Right.
gas cap, I call it.
So is that now the standard? Like, or there are going to be multiple valves because again, each one may eventually choose. Like Chinese are coming on the private side, India is coming on the private side. If they choose their own design at a different entry, I mean, fueling law, then would you be able to create multiple valves that can connect to different companies' uh, gas storage?
It's a great question. There's going to be a network effect, right? The more interfaces that are in orbit, the more people are going to look to use the one that's in orbit more. So we set the company up about 2 years before Space Force was established, and the U.S. government is by far the biggest single customer for space assets and the like, and has the biggest immediate need for fuel in orbit. And what we've seen now, having had our fueling interface approved for inclusion on some of the biggest national security assets, just last week, a solicitation came out for spacecraft that said, we want refuelable spacecraft and they have to use Orbit Fab's Rafty interface. So the US government is now our marketing department. So we're on track to be not just the de facto standard, we think it's going to become the official standard in a few years' time.
That's awesome. And just an add-on quick question is, in the making of those valves, obviously they're made here and shipped to the orbit, or you can make it right then and there.
So we ship them to the satellite integrators, who then integrate them on the satellites, put them on the rockets, and they go to orbit.
But eventually you should be able to make them right on the moon surface or...
If you were building spacecraft on the moon, then that would be the place to build them. Yep.
Yeah, I had the same question on the gas cap.
Mhm.
Right now, it's your proprietary
Correct.
design. Are you planning to create a standard out of it where you license and get a license fees?
Yeah, so we've already said to the industry that we're going to make this available under an open license, which is an undefined term. But we have an agreement with one of the biggest valve manufacturers that they will be effectively be our channel partner. And if we get an order from a constellation for 1,000 valves or 10,000 valves, they'll do the manufacturing on that because they're set up to do the mass production. So customers could buy the valve from them or from us and get the supply. We're also talking with a European manufacturer because they want to buy a European product. That's the valve. The active side, we don't need as many of those. We only need them on the delivery vehicles. So at the moment, that's a fully proprietary interface. If the US government says in a few years' time, this is now the standard, and we intend to publish an ISO standard or something like that, then anyone who wants to create a competing product has to now engineer their own valve, and they've got to look at our patents and either get around them or license them. Even if they're able to do that, we've got a head start. We've got the long-term contracts in place, the IDIQ type things with the government. We've got our fuel depots and our logistics built into the launch companies, and we've already got LOIs and the like that are getting turned into contracts there. We've got all the flight heritage and all the experience with our interface. And in a risk-averse industry, people always go with the thing that's flown before. So we end up in a very commanding position and establish ourselves with the take-or-pay contracts, the finance and the cash flow to continue then to leap beyond. So we start doing in-space chemical conversion whilst people are still trying to catch up on the interface. We start doing expansion horizontally into other propellants, into other services like warehousing, right? The whole logistics supply chain is in ours for the picking. So even though we think that we've probably only got 6-7 years of proprietary nature of that fuel import, that's more than enough to cement our position in the industry.
And the other part is the docking with the. So how much of that technology has been mastered so they can do it repeatedly?
Yeah, so our nozzle, our refueling nozzle, is actually a robot hand that directly docks. So that's key to it. The guidance and navigation system, we did a lot of work on that and realized there are a lot of companies building it. I draw the analogy to self-driving cars. About 8-9 years ago, if you could get a car to drive around a parking lot, you had $1 billion startup. Within a year, you could buy that kit for $30,000, and in a month you could make your own self-driving car. That's where we're at now. It's now on the edge of being a product, right? It's a technology that's been done. It's a project you can hire engineers to do, and there are 6 or 7 companies that are developing a product, a kit that can make your satellite self-driving to do docking. So we backed off and said we want that to be a product. We don't want it to distract us from delivering fuel, so we're going to buy that product. So we went and teamed up with 6 or 7 different suppliers around the world and said, like, we want to have access to your technology to be able to do the guidance and navigation.
So all the thrusters and all the configuration and manipulation to get close to the user is all you're buying it from
So
third party.
we don't make satellites. We're not making the guidance cameras. We are buying those. We make the interface. We focus on the key thing that we need to do, which is the interface and the systems engineering and the customer contract. So we own the interface, we own the customer contract. Those are the key things for our business. And that frees us up from a large capital expenditure that other people are trying to focus on to be the best in the world at making satellites, making thrusters, making guidance cameras, those types of things. So very much a focused strategy on how to reduce capex.
So it will be third parties which will be having this, the delivery satellites,
No,
or
so
objects in the.
we'll own and operate the delivery vehicle.
Okay.
We'll own and operate the depots, and we sell the gas cap and we sell fuel.
So how many delivery vehicles would you need to be orbiting?
It depends on how big the customer base is. At a minimum, we need a couple of shuttles, fuel delivery vehicles in geostationary orbit, and 4 to 8 in low Earth orbit to serve the different inclinations. But we build that out in response to demand. And we've got a model. It's surprising how much data a customer will give us on their constellations and those kind of things. So we have a model that takes that into account to optimize the distribution of our network to be able to reduce the cost. It also gives us incredible insight on how to do pricing strategy, which of course is based on their next best alternative. And the information that we gather from them, they give us information to tell us what their next best alternative is. We end up, for example, with the Space Force and some early contracts, we're creating, one example that we ran was creating $800,000 per kilogram of value. And we're charging $200,000. Like, we're giving up too much here, but our gross margins are 90% at that. Right? That's how much value there is in this transaction. It's an incredible business.
If I'm a satellite salesman,
Yeah.
I hope you fail spectacularly. Who else is hoping you fail?
So, actually, no. I got two ways to incentivize. One, I got a lot of margin here. I'll give you a cut of my fuel sales. You may make more money off a percentage of the fuel sales than you did off making the satellite.
Yeah.
The second thing is just a call to history. Every time things become more efficient, the quantities go up.
Yeah.
I got a great graph of lighting. Right, the worst thing that happened for the environmental movement was LEDs, because lighting is now so cheap that we put in here for accents and everything else, and the amount of energy that got consumed in lighting went through the roof. LEDs are terrible for an environmental movement if we believe we should be reducing energy. That's why nobody is actually scared of making these satellites reusable, because the quantities will just keep going up as the cost comes down.
Do you envision a time when you're going to need to put air and water
Absolutely.
in space?
Yep, I envisage a time when water is mined from the moon and asteroids, and we turn that into air and water. That's where refineries will go. That's our 20-year vision, is to be the dominant downstream oil and gas, refineries, storage, and distribution. Standard oil in space.
In fact, mood is like right now is like the choicest place. But if the start station there, you don't come back to it every time.
Oh, I was an asteroid miner. We're going to have a religious debate about moon versus
totally.
asteroids.
I'm totally for. I'm pro. But right now, I think there's limited access that we have. We can leverage for further exploration.
We're going to have to talk more about this later.
Can you talk a little bit about satellites lifespan?
Yeah,
How
absolutely.
that changes, how it intersects with components lifespan on the satellite?
So 85% of satellites are thrown away because they run out of fuel. Not because their customers have stopped buying the product because the technology is old, not because they have failures in the equipment, but because they run out of fuel. And you have to get them out of orbit. Right? You need fuel to just put satellites back where they're supposed to be. They keep drifting. The moon pulls them, the sun pulls them, the Earth's gravity field is lumpy. You're using up, in geostationary orbit, they use 50 or 60 kilograms of fuel every year just to make sure they stay where they're supposed to be, which you can imagine from a national security perspective is terrible. You're using all that fuel just to be in the most obvious place. Right? From a business model perspective, you've got no flexibility. You've got just enough fuel to do just that thing. Right? So lifetimes, some of the satellites in geostationary orbit are planned for 15 years. The low Earth orbit ones tend to be planned for sort of 5 years. And there's a lot of interest in the shorter lifetimes because you can do technology refresh more often. But every time you do a tech refresh, you've got to build an entire tightly integrated satellite and launch it. And if you look at the constellations now, Starlink, Amazon Kuiper, Telesat, OneWeb, there's a whole bunch of them. Their business model is to spend $5 to $10 billion every 5 years to replace the entire constellation. Think about how we do it on Earth, right? We have a cell phone tower. There are millions of them. And we go from 4G to 5G by taking the transponder off and putting on the new transponder. I don't have to rebuild the hill. I don't have to rebuild the fiber optic, the tower, the power supply. It's all there. In space, we throw all of that away and we start again. And yet still, Starlink is starting to eat the world of telecoms. We sat down with the chief of supply chain of OneWeb, one of these constellations, and said, look, here's what we're going to charge for fuel. And here's what we know about the satellite servicing companies. They're basically tow trucks. They can remove and install payloads. They can tow debris, those types of things. They're our natural customers. They need a lot of fuel. Right? Here's what we know about them and where their input costs and what their pricing is going to be. He came back and told me, did the math, instead of $5 billion in 5 years, it'll take 1 year to do an upgrade. And it'll cost $500 million. So a factor of 10 less, a factor of 5 faster. You get so much closer to the tech curve and to Moore's law. And you drop that capex cost, you drop the price of doing telecoms in orbit to the point where it's compatible with fiber. $2.7 trillion telecoms industry is all going through space at that point. There's going to be hundreds of thousands or even millions of cell phone towers in space, just like there are on Earth. Our market goes from the current 10 billion a year to 100 billion a year. That's our upside.
So what's the next immediate after the gas cap? Obviously, that's the starting point.
Well,
But what's the next product line? Because once you're in, like you corner the highway.
Yeah.
Now you can just start wrapping up. According to you, what are you most excited should be the next thing right after that?
So we're selling gas caps and we're selling fuel,
Okay.
right? And we're on contract to deliver fuel for the US government next year. So that's game on. Like, as soon as we've done that, all the commercial companies have said, as soon as the government has paid you to do that, you prove it, we are coming to beat your door down, right? And so will everybody else. That's a direct quote from an executive of the largest
So where do you
telecom
still see
company.
the gas from?
There are terrestrial suppliers, right? We're storage and delivery. So we buy it, we launch it, put it in orbit. The suppliers is a fairly well-known market, and we actually hedge that. So in our forwards contracts, we'll put escalation clauses. So if there's a rise in price, the customer pays. If there's a drop in price, they benefit. We also put an escalation clause in for launch because launch prices have been falling,
Yeah.
and the customers don't want to sign a forwards contract if they think it's going to be cheaper in the future. So we simply take that and say, well, as that drops, we pass that saving directly on to you. So we're able to isolate ourselves from those risks and pass the perceived benefit
Oh, yes.
to the
So
customer.
many revenue opportunities.
We do.
Crazy.
The largest part of Orbit Fab may be the bank.
Maybe I missed this, but are you able to retrofit existing?
No, we made that decision. That's a strategic decision we made. NASA spent $1.5 billion trying to do robotic surgery on a satellite in orbit and put fuel into something unprepared. And then they canceled the mission because it was going to cost another $1 billion to finish it. And people have started buying our interface and they realized it wasn't relevant to the economy anymore. So if you have a satellite that's legacy, that doesn't have the interface, or if you've got one that's like wobbling or got a scratch on the indicators or something like that, call a tow truck. I'll give you a list and we'll refuel the tow truck so we can indirectly help you.
So one more we're missing is SpaceX. Is there a reason why?
Sorry, what was that?
In your commercial wins, I don't see a SpaceX logo. I see Firefly.
Oh, SpaceX are a great supplier. The last 3 launches we had were on SpaceX. We've put in some proposals to the government with SpaceX as a partner. None of those have won, but they're a good supplier. But they're focused to the point on the Starlink side, on these fully disposable satellites, on investing. They've invested an enormous amount of money in their satellite factory and their rockets to be able to launch hundreds of thousands of satellites. Everyone else in the industry is terrified. And every time we talk about the cell phone tower, the upgradable satellite, everybody realizes that's going to completely sideline all the investments that SpaceX has made. So while SpaceX is currently a telecoms company with a rocket problem, right? They're a $350 billion company on the telecom side and a $20 billion company on the rocket side, right? But that rocket side is something that's almost unassailable in the next few years. Whereas the telecoms companies are realizing if they switch to a new technology generation, they can leapfrog that. And so they're all very, very excited about the kind of things that we and the satellite servicing companies, our customers, are all building, and they're looking to make sure that's well capitalized.
What's that option? Understand that maybe missed it. It's already there. Was the percentage of the satellite support and versus?
Yeah, so our biggest competition is non-consumption, is people putting up assets without fueling ports going forward. And so last year we finished the flight qualification of the fueling port. We sold 50 fueling ports on a total of, when we exclude like the mega constellations and everything we're not targeting yet. That's 50 out of 600 satellites in the addressable market. So decent penetration. But we need to make sure this continues and absolutely lock it in. And the big push this year, and we think this is about to happen, the US government to require every single asset that goes up to be refuelable.
Is this like chicken and egg? So they're waiting for you to have a gas station in the orbit before they adopt the standard?
So that was the problem on the commercial side. We ran into that. But the government is so desperate to have this, it's so important for them, that they're just getting ahead of it and saying, no, we're going to put the gas cap on there because we've de-risked that. We've demonstrated it doesn't leak. It's reliable. You can use it, just replace the valves you currently have. It's a no-brainer. And even if you never use it, if you're trying to counter that capability, now you know that the US can just maneuver without regret, right? You maneuver as hard as you like today and refill it tomorrow. Countering that just became infinitely expensive, and it continues to be a deterrent.
Can you refuel Chinese satellites? Or?
Not if we're doing. Yeah, it's a good question. Not if we.
Coming.
Yeah, not if we're doing business with the US government.
Okay.
Yep, it's a good question.
Tariffs.
600 days.
I'm feeling like an attack. So, what about solar powered satellites, nuclear powered satellites? How would they impact your business?
Yeah, so important to realize. All satellites are running off electricity to run their avionics and things. It's pretty much all powered by solar. There are some deep space spacecraft that use nuclear power, but that electricity can't help you move. If you put a Tesla in space, it'll spin its wheels all day and not go anywhere. There's nothing to push against. A Tesla on the road pushes against the Earth, and that's how it moves forward. So we've got to take some of the Earth with us, and that's the propellant. So even more important than the energy content of the fuel is the mass that you can use to throw out the back. So there are electric propulsion systems, and there are chemical propulsion systems. In chemical propulsion systems, you burn the propellant, it gets nice and hot, it goes out the rocket motor, and you go forwards. Electric propulsion, you have to have a propellant, and it's usually like a noble gas, xenon or krypton, and you ionize it and accelerate it out the back. And it goes out a lot faster, so you're much more fuel efficient, but you still run out of fuel. It's also very power hungry, so you need big, heavy solar arrays, which is expensive. And it's very, very slow. It's a very, very low thrust because you're throwing out like small numbers of atoms every time. And so it takes a long time to get to an orbit where you can start generating revenue. In fact, it takes 6 months for these satellites to get to operational orbits and geostationary orbit. They can lose the first $100 million of their revenue. So as soon as you got refueling and you care less about the fuel efficiency of that one tank, everyone's probably going to go back to the slightly less efficient chemical propulsion, which is great because they'll need more fuel. But either way, the electric propulsion spacecraft do also need propellant. And our European office has a contract with the European Space Agency to deliver xenon for electric propulsion in low Earth orbit. So we've already got that technology mostly developed and ready to go.
Okay.
Yep, great question.
China is already working on the ion thrusters, right?
Everyone has ion thrusters. This is one of the technologies for electric propulsion.
Yeah.
Yep, but they still need propellant.
So if you had a lot of funding and you just added $100 million to triple that $360 million in potential contracts in 3 years, what would you spend it on?
The most important thing for us is that every government asset is refuelable. So right now it's government affairs. We just hired our first lobbyists. This is how the aerospace and defense game is played. We need to have somebody walking the halls of the Pentagon and Congress and embedding our architecture, embedding the refueling architecture and everything into the thinking in those places. That's the first thing. The second thing is we need to be incentivizing the commercial customers to come on board more quickly. So if I had more money, how would I accelerate? I'd do my own fuel shuttle, I'd do my own delivery, and not wait for the government delivery, which is the middle of next year. I can get that done 6 months earlier. It'll open up the market quicker, right? But to be capital light, we've got all these government contracts, and our revenue to expense ratio has always been pretty favorable because we've been able to pick up those contracts. So that's a trade-off, right? And it comes down to the risk appetite of our investors. And currently we're being told, okay, great, the government contracts is a good pace. I can always up that pace if I have an investor that's more aggressive.
You take check?
You bet. I'll take Bitcoin. I've done that before.
Even better. What's the burn right now? I mean, you raised 40 million. And
Mhm.
how are the unit economics panning out? Because it's just the beginning.
Let me give you an idea of the unit economics. So we're talking about $100 million potential plus up on our government contract. It's 500 kilograms of fuel. For $100 million, I can buy a SpaceX Falcon 9 and a boost stage to get from low Earth orbit to geostationary orbit, and a delivery vehicle once I get there, and put 7 tons of fuel in orbit. And I recoup it all for the first 500 kilos. It's not bad margins.
That's not bad at all.
Maybe a question for both of you. So, if we're building out this space logistics infrastructure, and that allows humanity to explore our galaxy and beyond, what does that mean for us? Like, what's the future we're looking at?
Cool. Let me give you a few examples there. In space, you have the advantage of zero gravity. If you think back 150 years ago, somebody invented the first, I wish I had their name, invented the first industrial vacuum pump. And now you could suck the air out of a jar on an industrial scale. What do you do with a jar with no air? Well, everything. Try and build a factory without a vacuum pump these days, right? You get vacuum freezing, refrigeration, all these chemical processes that happen at variable pressures. Right now, we're on the verge of having industrial access to zero gravity. I can take the gravity out of the jar. Now I have a jar with no gravity. What do I do? Gravity is the force that organizes matter at a macroscopic level. Buoyancy is a gravity effect. I can mix things that have never been mixed before. There are people looking at manufacturing pharmaceuticals in orbit you can't make, manufacturing materials in orbit that you can't make on the ground. We're going to have various parts of the manufacturing chain that are done in space. You end up stitching the whole thing. I can see most of manufacturing moving to orbit. I can see power generation moving to orbit. Let's do nuclear in space. I don't have to worry about shielding, right? And I don't have to worry about things going wrong as much if I'm not on Earth. Or solar power, where you get 1.3 times the energy, and it's there 24/7, right? Combine that with the fact that if I rotate a cylinder, the centripetal force looks like gravity. I can create a variable gravity. It's going to be fun for tourism. I'm going to have some great zero-G football games. But also, it's going to have less pressure on my heart if I go to a level that's got less gravity. I think aged care moves to orbit. Let's all retire to orbit. You'll live twice as long. Let's move medical care to orbit because I can vary the pressure on your heart and your body. Great for physical therapy if I go to the high G region. Great for recovery if I go to a low G region. I just moved medicine to space. How much of the economy do I have to move to space before it's a really interesting place to live and most of humanity are up there and we come down to Earth to visit a nature reserve? That's how we go to negative CO2 emissions. That's how we save the Earth. That's the future that my kids are going to live in.
Amazing. On that note.
Thank you all.
Brilliant.